I think most people have got part 3. So as you're writing down the others, let's just go through that one together. With part 3, who used product rule here? Pretty much everyone. Did anyone expand? Josh and Cameron. Crazy, crazy algebra nerds. Okay. Which one is better? I mean, honestly,
Less effort, right?
Was it less effort? It depends. I found that people made mistakes either way. So one thing I will say though is I think that if you're expanding because you don't like using product rule, then you should probably make sure you are comfortable with product rule. Expansion is actually a useful skill as well. So I think both are good skills to have. But yeah, you shouldn't be avoiding one strategy. You shouldn't be doing one strategy to avoid another one. Let's go with product rule since we're working with calculus anyway. Liam, you want to walk this one through with me? Yeah.
So it's going to go to x
Yep.
minus 2 all squared
Sure.
plus x plus 1
Yep.
times 2 times x minus 2.
Yeah, cool. So you took the derivative of that, that's fine. Yeah.
Next one is x minus 2 all squared
Yeah.
plus 2x plus 2
Sure.
times x minus 2.
Yeah.
I've got to read my writing.
That's all right. I believe in you.
X minus 2 squared
Yeah.
plus 2x squared minus 4x plus 2x
Yep.
minus 4.
Yep.
And it's x minus 2 squared plus 2x squared.
You really like leaving this x minus 2 squared here. You could expand this one, honestly. I'm going to expand it for you. I'll save you a few lines. Yeah.
Plus 2x squared
Yeah.
minus 2x minus 4.
Sure. Plus,
Minus 2x.
yeah, okay, cool. Plus, minus 4. Yep, cool.
Yeah. And then x,
Some nice simplification.
so it's x squared minus 4x. Huh? Oh, that's the one where we got.
You can probably just simplify here, right?
X squared
Yeah.
minus 6x.
Yep, so 3x, you say 3x squared?
3x squared
Yeah.
minus 6x.
Yeah. Because this cancels out of that, these two together, minus 6x. Cool. And so I guess to answer the question, right, how do we know when it's stationary? Well, we let f dash of x equal to 0. So we get 3x squared minus 6x equals to 0. What do I do next? Factorize, good. Why don't I divide? By x. Why don't I divide by x?
Because that's assuming that x is not 0. If you were to divide by x,
Yeah.
then you would be making an assumption that x is not 0.
Yes, that's true. That is true. There's another good reason. The reason is, so what Cameron is saying is that, so let me just take a step back. Often a piece of working out that I see from students is that they'll divide both sides here by x, right? That's sort of a step they'll do. They'll treat it like a number, and then they'll get this answer here. But what do you notice about this answer compared to your answers? Exactly right. So 0 is a solution. So what that means is you actually tend to lose solutions when you divide by a variable as well. Okay, so it's really important, as Chelsea did, you factorize. And so then you get all the solutions that you're looking for. Okay, x equals to 0 or 2. Now, I haven't actually asked you to do this, but what kind of function is this? Cubic. And cubics look pretty funky, little waves going on, things like that. Extension 1 students, you actually have strategies to sketch something like this. Does anyone remember any properties there for sketching? Caitlin?
Well, you know the x-intercepts
Yep.
are -1 and 2.
Yep.
It'll do a little bumpy thing.
Little bumpy thing. That's the technical term. Yes. Oh, Chelsea remembers from.
I kinda remember.
Yeah. And that's actually a really good strategy. You guys have a little bit of advantage when you look at curve sketching. Also, these two are a bit of a hint for you. What's happening at 0 and 2? Stationary points, right? So, wait, 0 and 2? Oh, so 2 is also a stationary.
It bumps
Ah, okay. So it looks something like this. Is that what you're saying?
Yeah.
Yeah. So this should be. Oh, is it 5? Oh, you actually found it for us. Perfect. Okay. As you can see, curve sketching is not my forte,
Hey, so it
but
needs to be one continuous line.
is
So you didn't label the
half,
equation.
2.5 marks. What do you reckon? X, Y. I have marked people down for that, so just let you know. So what I'll say about this is the reason why I bring it up is because in a few lessons time, we'll actually look at how can we really sketch these using the advanced method. So only basically using calculus. The trick that the Extension 1 kids are familiar with is that if you ever have something to the power 2, it actually behaves like a parabola at that point. So you can see that kind of bounces up, just like a normal parabola would as it touches its stationary point there. That's just a little bit of an idea to get you thinking about how this relates to curve sketching. But let's look at this one, because number 4 is really like the exam style question that I really like looking at. So I'll find the derivative for you, save you a bit of time. F dash of x is equal to 3x squared plus 1. Josh, is this going to be an increasing function?
Yes.
And is it always going to be an increasing function?
If what you told me earlier is to be believed, then yes.
What did I tell you earlier?
You told me that it is always increasing because the squared in that derivative makes every number in a positive. So it's always positive, therefore always increasing.
That's right. And so here's the problem, because show questions students traditionally have trouble with, right? And kind of earlier I mentioned that often the curve changes. Sometimes it doesn't though. Sometimes curves are actually always increasing, as it is in this case. And I guess to show that, there's no reason why you can't use words. Like Josh was saying, you could say since x squared is always positive, right? 3x squared plus 1 is always positive.
Therefore.
Yeah. If you don't want to write always positive, you can just say, actually, you can always just say greater than 0. Oh, I'm going to talk about that in a second. Since x squared is greater than, you can say it's always increasing if you want to save a bit of writing time, right? Does that make sense there? Because basically I'm saying that since the gradient is always going to be positive, rather than trying to test individual values, oh, is it true for 1? Is it true for -1? Is it true for whatever value? You can just say generally, since x squared is greater than 0, then 3x squared plus 1 is always greater than 0. And so therefore, f of x is always increasing. But Caitlin, you had another idea. What was that?
To just draw the graph and show that it's always above the x-axis, which means it's always...
So the graph of this is a parabola. It will look something like this. Mark my axes in this time. Is this a proof?
Instead of y, would it be y dash?
Yes, that's actually a good point, probably, actually. Yeah, f dash of x or, yeah.
If you the graph and then explain
Yeah.
the graph,
Yeah.
would that be a proof?
What do you guys reckon?
Yes.
Yeah?
Words better.
Works better?
Words are better.
Words are better.
It's showing.
Yeah, Cameron?
I agree with the graph, but then explain what was going on in the graph that was always above the x-axis and therefore positive.
I think if you do that, I think that should be okay. I will double check for you. But this is another question like when we talked about even and odd functions, if you remember back to year 11, like, can you just sort of draw it and then talk a bit about the properties of why they're even and odd? Do you have to do the algebraic proof? Traditionally, most people and most work solutions will have something like this. I think this is actually okay, as long as you're explaining what very clearly what the significance is, right? You're saying that all of the values is going to be positive. In fact, I don't know if you've learned this sort of language before, but I think this is a positive definite. Have you guys looked at stuff like that before? Positive definite parabolas. I will just double check the terminology. So a positive definite parabola is one where it's always above the x-axis, and it doesn't have any x-intercepts, and it's positive. So we're saying that it's a concave up parabola. If you were to have like a negative definite parabola, it'd be going the other way. It'd be going like this, right? So that's a negative definite. And that's important because if you ever want to show that parabolas are, gradients are always increasing, always decreasing, then you'll probably want either one of those two situations. Yeah, okay. Cool. Last one. Part 5. Show. Oh no, I missed one. Sorry, thank you. Got too excited. Okay, part B. You don't know how to crack a part B. That's a weird one, isn't it? Sorry. Find f of 0, find f of 1. That's the easy part. I'll give that to Theo. F of 0?
Equals 3x squared plus 1. We're just bring, 1.
Ooh. Thoughts? Good, Felicity, yes.
There
very careful with there's no dash. So, and it's very important that you'll see why we're looking for the original function in a second. But yes, look carefully at what you're substituting into. Yeah. Lily, what's f of 1? 1, yeah. So, sorry, I was in my own world. Now, who can have a crack at answering this one? Explain, I'll underline explain, because they're starting to ask a lot more of these types of questions in HSC exams. Explain why there is only one x-intercept. So explain why there's only one x. If you graph this, by the way, there is only one x. It's not a trick question, right?
Yeah. With the fact that it's always increasing, so it can only go past x axis 1.
Good, that's exactly why it is, right? So think about it this way, right? You've got a point on your graph where this curve is negative. So at some point, it's negative, and then at some point, it's positive. If your curve is always increasing, I don't exactly know what this would look like, right? But if your curve is always, it probably doesn't, let's be honest, it doesn't look like that, okay? Whatever it is, it's not that. But if the curve is always increasing, can you see why in this situation that if you have some point where it's negative and some point where it's positive, it can only have one x-intercept, it can never go back. I guess the tricky thing is how would you describe that? You'd have to combine both of those, right? So you could say, since f of x is always increasing, f of 0 is negative or less than 0, f of 1 is positive or greater than 0, and here's the most important part, and it is continuous, so it's just there's no breaks or anything. Then it only has one x-intercept. Okay, so that's an exam style question where you actually have to do a bit of explanation, and that's quite common nowadays, right? Especially those harder types of questions. It's not just straight up, can you find whether it's increasing or find whether it's decreasing? Those are the types of questions which are a bit trickier. The last one I'll let you do for homework for me, along with 6.01. Didn't you guys write it down?
No.
I said someone needs to write it down. So that...
Did no one write it down? Oh no.
No one was up to it yet.
Tough times. I'll post it on Teams.